Okay, this is lesson 6.2, and in this lesson we're going to split into 6.2a, where I'm going to introduce those two solving strategies for solving a quadratic equation, and then in B we're going to finish the last two examples as applications. But to start, what's it mean to solve an equation? Well, to solve an equation, it means find the value of the unknown. And in this case, if we were solving this equation, 4x minus 7 equals 1, we would want to figure out what x is. So we're trying to find the value of x, which satisfies the equation. And to do that, we would just isolate. So if we wanted to solve it, we just would take the negative 7 to the other side by adding 7. We'd get 8, and divide by 4, we get x is 2. And this is called the solution to the equation. It's also called the root of the equation. It's called the root. X equals 2 is the root. Or we could say solution. So what's different about solving a quadratic equation? Well, like x squared plus 5x plus 4 equals 0. What's different is there are two x terms, unlike x terms. So we can't just collect them and then isolate, because we can't isolate if there's two different terms that have x. So to solve this equation, we have two methods. And we're going to explore those below. But before we do that, we're going to discuss three words that are kind of sometimes used interchangeably that I want to clear up. The solution to a quadratic equation is known as the roots of the equation. If we have a quadratic equation set equal to 0, what we'd be doing is we'd be solving for the zeros. And if we were to put those on a graph, they would be the x-intercepts. So the words zeros, roots, and x-intercepts are sometimes used interchangeably. I want to show you what they mean. X-intercepts, if we had the equation y equals x minus 2 and x plus 2, we could find them because each of these brackets leads you to one x-intercept. The x-intercept here would be 2, 0, and the x-intercept from this bracket would be negative 2, 0. The x-intercepts are points on a graph. And they are at this point and this point. So when you see x-intercepts, keep in mind that they are points on a graph. Zeros are the roots of the equation when y is equal to 0. So if we have y equal to 0, the roots tell us that, well, x equals 2 from that bracket, and x equals negative 2 from this bracket. So these two values, 2 and negative 2, are called the zeros. So they are values of x that produce 0 for y. And finally, roots are solutions to an equation. So for example, if we wanted to solve the equation x minus 2, x plus 2 equal to negative 4 from the graph, if we want to take a look, where does our parabola equal negative 4? Right there, at x equals 0. So x equals 0 would be the root of the equation negative 4 equals x minus 2 times x plus 2. Now, not to confuse you, but these values, 2 and negative 2, are also called roots. They're the roots when the equation equals 0. But in this specific case, when the equation equals 0, those are also called the zeros. So zeros and roots are fairly commonly misstated, because when you solve an equation equal to 0, you are finding the roots, but those roots are called zeros. When you have points on a graph that cross the x-intercepts or the x-axis, those are called x-intercepts. But sometimes these three things are used interchangeably. So what we're going to do in this lesson is we're going to solve a quadratic equation. So when we do that, we're finding the roots. Sometimes those roots, because they're roots when we're solving an equation set equal to 0, are called the zeros. And when we solve set equal to 0, we might plot them on a graph, and then they're called x-intercepts. So you can see maybe why these words are used interchangeably. You're going to spend the next couple years getting a handle on these three words, so it's not completely necessary that we master them right now, but these are three words that are sometimes used interchangeably, which probably shouldn't be. Back to solving. So, two methods for solving. We can solve by completing the square, or we can solve by factoring, and I'm going to show you both strategies. Solve by complete the square and solve by factoring. And I'm going to do that on the other side. What I've done here is I've written a couple steps on how to do both these methods, but I'm just going to show you using example 3. So let's flip it over. So we're going to solve this equation. 0 equals 3x squared plus 30x plus 75 using two different methods. Now, since this quadratic expression is set equal to 0, we are solving for the zeros because it's equal to 0. But the solution to this is also called the roots. So you can use zeros and roots interchangeably in this example. So let's find the zeros, or let's find the roots of this equation. First, we're going to solve by completing the square. Now, even though we're doing this example first, most mathematicians don't necessarily usually solve quadratics by completing the square. They usually solve by factoring. But I'm going to show you both strategies, and then you can choose. But solving by factoring, I think, is more versatile. So most will solve by factoring, the second example. And you'll probably see why when we actually solve this by factoring. It's a little bit quicker. So to solve this, we actually have to complete the square. So 0 equals, we're going to group our first two terms and common factor the 3. So 3x squared plus 10x plus 75. I did two steps at once. I did the grouping in my head and I divided 3 out. Now we take that 10, divide it by 2, we get 5, square it, we get 25. So we're going to add and subtract 25. Plus 25 minus 25. And now we're going to bring that negative 25 out of the bracket by multiplying by 3. Negative 25 times 3 is negative 75. And now we're going to collect like terms on the outside, which actually end up being 0. And we're going to factor our perfect square trinomial. Square root of the first is x, sine from the middle is plus, square root of the last is 5. So now we have this nice equation. Now, why do we complete the square to solve? Well, look what happened when we completed the square. We started with two terms that had an x, and now we just have 1x. So now we can start isolating. First step is to divide away the 3. 0 divided by 3 is 0. And we get x plus 5. And if we square root both sides, remember to take both the positive and negative square root. Of 0 is just 0. But if we were taking the square root of, say, 16, we have to write plus and minus 4, so we get two answers. Square rooting over here leaves us with just x plus 5. And now finally we can move the 5 over, and we get negative 5. So there's our solution. One solution, actually. We only have one solution. So this quadratic has only one root, or 1, 0. If we want to solve this by factoring, let's do that. We've got 0 equals 3x squared plus 30x plus 75. The first thing we should do when factoring is look for a common factor. 3 divides into 3, 30, and 75. Perfect. So we can common factor 3. That leaves us with x squared plus 10x plus 25. And now, to factor x squared plus 10x plus 25, that actually kind of looks familiar to this. And it's because we have a perfect square trinomial. Or, if we didn't identify that, we'd just be looking for numbers that multiply to 25 and add to 10, and the answers are 5 and 5. So we'd make our two brackets, x, and the numbers that multiply to 25 and add to 10 are 5 and 5. And since we have the same bracket, we only have to write it once. And now, once you have something in factored form, to solve it, you just take the bracket and set it equal to 0. And then solve for x. And we get minus 5. So, same answer. Either way we solve it, completing the square or factoring. It's up to you, but we come up with the same answer. And that's it for part 1 of lesson 6.2. Come join me in part 2, and we'll look at example 2 and example 3.